Hi guys, back to do page 164, 29b. And B says that if I have a sound source that is has an intensity of 12 watts per meter squared, when I'm 2 meters in front of it, how far away do I have to be in order to receive 10 milliwatts per meter squared? So I'm going to start out with the relationship of intensity is proportional to 1 over x squared. It's one of those inverse squared laws. So if I have an intensity of 12 watts per meter squared, first of all, what I want to find out is what is that K value, that proportionality constant. And so I'll just say K times 1 over 2 meters squared. So if I do my algebra here, I'll find out that my K is equal to 48 watts. All right, so then what I have to do is I have to say, all right, I'm trying to find out the distance that I would have to be, all right, so how far I would have to be to get 10 milliwatts per meter squared. So the first thing that I'll do is I'll convert the 10 milliwatts per meter squared to watts, and that's the easy calculation, 1 watt over 1,000 milliwatts, and I get a value of 0.01 watt per meter squared. Okay, so then I'm going to go back to my equation, which is intensity is, now I can say it's equal to that proportionality constant K over x squared. So if I now just take my value of 0.01 watt per meter squared, set that equal to 48 watts, which is what I calculated my K value to be for this example. It's the proportionality constant for this example, and I'm then going to multiply by 1, but well, you know about that, over x squared. So then I just have to solve for x squared, and so x squared will be equal to 48 watts over 0.01 watt per meter squared. And then I'll find that x squared is equal to 4,800 meters squared. Then if I take the square root of both sides, I'll find that my x distance is 69 meters. So that's my answer as to how far I would have to stand in order to receive that 10 milliwatts per meter squared.